All right, so this is part 2 of our Glow Predictor blender model. We're going to still go over a little bit of the environment before we get into the prediction part so that you're comfortable with that. So we've talked about how to move in the space in part 1. We've talked about, this is our animation bar in the scene. And now we're going to talk about the collection. So we have our light, a sun location, a compass, the earth, and some constraints, or basically modifiers to allow it to spin. We have an empty, an equatorial, and the poles. So basically these are just components of the model. So the compass is pretty simple. The compass is right there. We have an equatorial dial right here we'll be using in just a little bit. And we have the earth itself, and then we have the pole, and then we have our light. So this is our sun location pole. So it's kind of hard to see right now, but there it is right there. And it's pretty big. We probably need to make that a little bit smaller. So let's go down to 1,000. Okay, so there we go. So there is our sun pointer, essentially what it is. And what we're doing in this blender model is I have it oriented to where whenever I move the light position, that pointer is going to move as well. So let's get into how to get this thing working. Okay, so we have to orient the sun and the earth to a base point. So what we're going to do just for now is we're going to kind of hide these things. So you can select an object, and then you can go over to this object and you can close the eye. That basically means it's hiding it. So if I select this one and I go over and then I find it highlighted and I just close the eye, that's going to allow it to be hidden from us for the in the meantime. I'm trying not to cough here. Okay, so of course, here we are. So we have a very simple clock style orientation. So think about this as a clock. So when the earth is in this position, which is in a negative y position, right? The earth is in this position, it's in the positive y. This is the negative x, and this is the positive x. So what we have to do is we need to make sure our light source is aligned to the base. So we select our light source and we can look at our rotation. And we're going to always move on the Z rotation. So if we change this to 15, you're going to see that it starts to move that light, right? So if we go to 45, you can see now there's more and more and more. So what this is doing is this is aligning, it's actually moving the sun's light to a different orientation relative to the earth. These are going to represent our days. Okay, so 1 day, 2 days, 3 days, 4 days, 5 days. So we're going to put to 0. 0 is our 0 day, or our December 21st day. And if we move this to like 185 days later, around 180 days later, you're going to see that it's completely black on this side, and this orientation is going to be our June 21st time frame. 6 months later. It's actually not 180 days, it's a little about 185-ish. So we'll talk about that in just a little bit. But this is how we're going to orient our globe. So you pick your light source and we're going to match those days. But we always want to zero everything out. So you zero everything out here, or actually you start at number 2 because of the way the animation bar works. And then you're going to make sure your light is at 0. So now you have a zeroed out December 21st base. Now here's something that I was really struggling with until I figured out what I was doing wrong with orienting the earth. So we're going to orient the earth to the fall equinox. But what I wanted to show is this. We do know that the earth moves about 270 degrees between the December solstice or the winter solstice and the fall equinox. When you do it with just straight line math, you're going to get about 274 to 275 days. 1 degree is not exactly a day, or 1 day is not exactly a degree. It's actually 0.9856. So if you take the 275 days and multiply that out, you're actually moving 270 degrees in that 275 day count. So you got to really be specific when you're doing these alignments. So when I move the Earth in Blender, when I move it from the December solstice to the fall equinox, I'm going to be moving it 270 degrees, not 275 degrees, but because it's almost a degree, not a full degree. So just to let everybody know, when I do this, this is why. Okay, so now that we understand that math part, what we're going to do is we're going to take our light and we're going to do a rotation. Now again, we have to do those maths because it's not a degree per day, it's almost a degree per day. So if I was to rotate this, we need to rotate it to 270 degrees to match the fall equinox. So now we have the Earth in the position of 270 degrees, which is about 274 to 275 days, depending on leap year, or 275 days from December 21st to September 22nd, which equals to 270 degree rotation of the Earth. So now we're in the position of the Earth being at the fall equinox. Now you can do the same thing with the spring equinox. You just have to make sure you're doing your math calculations correctly, and then we can move from there. But as you can see, our little sun pointer is pointing in this direction. We are 90 degrees off of our December 21st alignment, and this is what the Earth would be doing on that. So if you hit the play button here, you're going to see the Earth do a rotation. And again, each one of these little markers, these little dots down here is half a degree. So every time it clicks one click, that's half a degree. And so we can test the positioning here. We can pause it. We can put things in certain orientations and test and see what everything's going to look like there. So this is how we get everything set up to be in the correct position. So again, you have to center everything out, right? We're going to take everything back to 0. And we take this, again, we can move this to actually 2, because it doesn't do anything on the first 2, right? And then we can put everything based on the December 21st time frame. And then we know everything's zeroed out. We know this is December 21st. And then we can move that according to roughly about, 1 degree a day. But once you start getting into the later parts of the month or the later parts of the year, you need to really multiply by that 0.985 to get your accurate rotational orientation, or you're going to be a little bit off. It's not too bad, but it is enough to make a difference. So this is part 2 of how to get this going and how to start getting your predictions. And in the next video, we will actually show you how to start using your predictions.